Welcome to today's AWS PartnerCast Mastering AWS Glue Series, Session 1. Before we get started, we wanted to let you know that you can get AWS trained, accredited, and certified from any location. There are lots of free virtual and online offerings for all your training needs, and all AWS certification exams now offer online proctoring. After today's session, we will send you a copy of the deck, as well as a link to all of the resources discussed today. If you have any questions, please go ahead and add them to the questions and chat window. We have a team member online ready to answer all of your questions today. This two-session series will provide a deeper understanding and best practices of using AWS Glue. It will cover the major AWS Glue concepts, components, and key features such as AWS Glue Studio and AWS Glue Data Brew. And with that, I'd like to hand you over to your presenter today, Vitor Freitas, Partner Solutions Architect with AWS. Over to you, Vitor.
Thank you, Karen. Hello, everyone. I am Vitor Freitas, a Partner Solutions Architect, Analytics Specialist, and today I will be presenting the first Mastering AWS Glue session. And I have with me my colleague Shunita answering the Q&A chat, so please feel free to ask your questions. And here's the agenda for today. It is a bit long, so I won't read through it just to save us some time. But basically, I will try to cover the most relevant topics about cataloging, tables, altering jobs, executing and orchestrating jobs in AWS Glue. And for tomorrow's session, we will dive deep into some of the new features of AWS, as well as we will cover some of the best practices. Let's start with a polling question. So you will see a question prompting on your screen. So please select the answers. Let me get the question ready for you. I hope you can all see the question now. The question is, rate your prior experience with AWS Glue from 1 to 5. 1 being I'm new to AWS Glue, and 5 being I'm an expert in AWS Glue. I'll give you like a couple of seconds to respond to that. Once we have everybody voted, we can move on. Please, I encourage you to vote. This is very important for us to track the feedback and improve. Okay, most of you are still voting. Give you a couple of seconds more. All right, that is good. Let me close the poll and share the results. So yeah, this is the results. Most of you are new to Glue, which is great. So I hope you can learn a lot on this session. And 24% of you had some knowledge, 80% also, and just few folks are consider themselves experts and very well versed in Glue. That is great. So let's move on. Let me close this and move on. So let's start our session today with an overview about ETL and AWS Glue in general terms. So surprisingly interesting, studies have shown that over 90% of ETL jobs in the cloud are hand-coded. There are multiple reasons why someone would like or would have to hand-code their ETL scripts, but there are also problems with that approach. That's a typical two-sided of a coin situation. So on the bright side, you get all the freedom and the flexibility to perform unit testing, integrate with different tools, and build complex CI/CD pipelines. But on the not so bright side, hand coding your jobs usually requires a lot of heavy lifting. Not to mention that it makes systems brittle and error prone, especially when data format changes, when the schema changes, or when you add new sources to the system, for example. But even so, with all these challenges and the risks involved, customers still continue to hand code their ETLs. And probably one of the big reasons behind that is the fact that there are many customers still using on-premise ETL infrastructure to process their ETL pipelines. And in fact, until recently, these customers had only two choices actually. Either continue to use these legacy, expensive, and proprietary tools, or switch over to an open source tool like Spark, for example, in order to avoid prohibitive licensing costs for their ETL tools. But again, in either the options, they would face challenges. In both cases, they would have to install, manage, and maintain those extremely complex infrastructure. And for those still running traditional ETL tools, they would also continue to pay hundreds of thousands of dollars to ETL vendors for products that usually are very expensive at the starting point and only comes with basic capabilities out of the box. So if customers wanted more fancy features, they would have to pay extra for capabilities like streaming, data catalog, semi-structured data processing, and so on. And don't even think about multi-node clusters with high availability configurations, because licensing fees get even more expensive for those and so prohibitive to many of the customers. And finally, regardless of on-premise or cloud, traditional ETL tools lock in transformation codes in proprietary formats and tools, which makes portability very hard, depriving the customers the opportunity to actually modernize their ETL tools. But fortunately now, more than ever, enterprise customers are embarking in the journey of reinventing their ETL infrastructure, all thanks to the Hadoop ecosystem, which was the biggest disruptor in that space. However, in order to modernize, customers are demanding systems that are reliable, operate at excellency, and can meet these four requirements. First, unified data platform, because customers don't want to buy individual components and stitch them together. They need an integrated solution for data processing. For example, customers expect ETL engines to be closely tied to a data catalog along with integrated security without paying extra. And the second is the augmented data processing. So artificial intelligence and machine learning is each day more present in our lives. So customer also wants to be able to infuse AI and ML into their data processing. And the third is open and interoperable ETLs, and that means open source, open source, open source. Customers do not want to lock their business logic into proprietary code anymore. They want to build the code once using open source tools and common language like SQL, for example, and then reuse it everywhere. And not only in the cloud, I really mean everywhere. And fourth, it's hybrid development environment. Sometimes visual tools make sense for entry-level developers to perform easy tasks, but still we all prefer to have options, right? So more experienced developers, for example, they prefer to have a code-based approach for complex ETL development and metadata-driven ETL programs. And with all this feedback in mind, we decide to build the AWS Glue. Glue is a fully managed ETL services that makes easy for customers to prepare and load their data for analytics. At its core, Glue has a data catalog, which is tightly integrated with various AWS analytics services like Lake-Formation and Redshift, for example. And Glue also leverages the powerful AI and ML transforms to clean and process data. And Glue is serverless. You're going to hear me saying that many times. So there is no infrastructure to set up or manage. Thousands of customers are using Glue to run their ETL jobs because you can just create and run an ETL jobs without effort in the AWS Glue console, in the Glue Studio, the CLI, using CLI, or even the APIs in your applications. Glue also offers what is the latest in terms of developing ETLs and processing near real-time data. That is why customers are modernizing their ETL solutions and taking all the cloud benefits. That means elasticity, flexibility, agility, scalability, and of course, lower operating costs with Glue. And here goes a simple, funny, but also very important, powerful motto about this service. So, well, building ETL pipelines is like plumbing, and like plumbing, we all expect it to be reliable above all. Customers want to be able to build reliable ETL pipelines that are simple to set up and at a lower cost. And of course, like plumbing, all of this should just work. And that is why we are so confident to say that AWS Glue is your friend in that space. And as we like to say, AWS Glue is a service for developers built by developers. But in order for everything to just work, we need to be able to support all the requirements expected by our customers and as many use cases as possible. For that, Glue service team and the AWS engineers, they work hard and constantly seek feedback to innovate fast in order to bring what is the latest in the ETL space, thus improving AWS Glue constantly. Look just at the past 12 months here. We have not only launched several significant features such as workflows, blueprints, ML transforms, data sharing, and streaming capabilities, but we have also improved many other areas for better performance, such as Glue 2.0, Spark Jobs, better monitoring capabilities with Spark UI, and continuous logging, as well as Glue availability itself. We shift that into more regions globally now. And like I said previously, we have thousands of customers using Glue to run their ETL jobs, each on its own particular way. And this is just a small list of customers that I want to highlight because it kind of shows different customers with from different industries. Okay, so it's time to start blazing our way towards learning Glue. So let me repeat this again. AWS Glue is a fully managed, elastic, and serverless ETL platform that allows you to discover and catalog data and apply transformation to clean, enrich, and move data. So how come that Glue can do all of that? Discover, catalog, transform, enrich, move data, etc. Well, to do that, Glue needs several components, which I like to categorize into 4 main macro steps. First is the discovery. This is where Glue can automatically find, catalog, and make sense of the data that it is processing. The second is the develop step. This is where the code to retrieve, transform, and store the data gets generated, manipulated, and customized. And the third step is deploy, which is basically where we decide how do we want our jobs to run and how fast we want them to run. And the last step, I like to call it do it again. This is where you can choose to leverage the work that has been done and then reuse it, automate it, or even share it with the others in the organization. And here we have a brief overview of the main components of Glue. The Glue Data Catalog, of course, which is a central repository to store metadata, and it integrates with various other AWS services. The Glue Crawlers, which is the component that automatically extracts metadata and creates external tables into the Glue Data Catalog. Then the Glue Studio, which is a new visual interface for authoring, running, and monitoring AWS Glue ETL jobs. This is very helpful for users with little to zero development experience, and we're going to cover it tomorrow. Dev Endpoints, which is an interface for users that want a notebook-style interactive ETL development. Serverless Spark, Dynamic Frames, and Glue Streaming. These are all micro-components, part of an interactive development platform for authoring and executing ETL jobs in Glue. And recently announced AWS Glue Elastic Views, which is a feature that enables building materialized views to combine and replicate data across multiple data stores without writing custom code. And at last, Glue Data Brew, which is a new visual data preparation tool that helps cleaning and normalizing data without writing code. There are many other components which I will cover in deep during this journey today. So don't worry, we're gonna dive deep into most of this. And basically, throughout today's session, we will take a look at each step involved in developing and maintaining CI/CD ETL pipelines from start to end. And it all starts with the data exploration, which is part of our discovery step. So let's start by looking at the discovery components, more specifically into the Glue Data Catalog, crawlers, classifiers, and connectors. And to help us during this stage of data exploration, 2 components are essential. Like I said, the Glue Data Catalog and the Glue Crawlers. Considering the principle of schema on read, the Glue Data Catalog allows us to use Glue Crawlers to automatically determine this data schema and create a Hive MetaStore compatible data catalog that is fully integrated with a range of other services. So what is the Glue Data Catalog in details? Glue Data Catalog is a Hive MetaStore compatible metadata store. It is used as a central repository to store a searchable metadata for your data lake and the big data workloads you have on AWS. This data catalog can connect and bring metadata from various data sources such as Amazon S3, Redshift, Dynamo, RDS, MongoDB, and JDBC sources deployed on AWS, or even on-premises data centers like Oracle, SQL Server, Postgres, and MySQL. So for a given data set, you can store table definition, physical location, and business relevant attributes in the Glue catalog database. And the versioning capabilities of the Glue data catalog actually allows you to track how the data and table has changed over the time. You can have one or more catalogs databases in an AWS account, and you can also enable cross-account access to a resource in the data catalog using a resource policy or an IAM role. You can also populate and manage table metadata using a Hive Metastore API, Hive SQL, bulk import, or automatically through Glue crawlers. And as you can see in this diagram, AWS Glue is tightly integrated with many AWS analytics services. The Glue data catalog can be queried and maintained through many services like AWS Glue itself, the ETL itself, Amazon Athena, Amazon EMR, and Amazon Redshift through Redshift Spectrum, for example. And at the same time, AWS Glue crawlers enables fetching data from many sources while having Amazon S3 as its final destination. Another important integration we can see here is between Glue and AWS Lake Formation. So Lake Formation creates an abstract layer of protection on top of the Glue data catalog that provides security and governance definition for consumer applications and services. And it also allows you to manage data lake permissions as if it was databases and to build data ingestion pipelines much more easily. But don't worry, I will cover the lake formation at a great extent tomorrow as well. Just a second. So back to crawlers. When we decide to create tables in Glue, we can do it manually through the Glue console and the create table API, or we can do it using automatically by using crawlers. Glue crawlers are processes that run against your data, and they detect the file type, they extract the fields, they define the schema, and they also identify partitions. You can use crawlers to create and manage schema and tables in the Glue data catalog. Crawlers are serverless, so you don't have to manage their underlying resources, and you can execute crawlers manually on demand, or you can schedule them accordingly. Also, you only pay when the crawler is running. And when you define a crawler, you choose one or more classifiers that evaluates the format of your data in order to infer a schema. Glue crawlers use these classifiers to automatically discover new data and to automatically identify the file types, partitions, and schema definitions. So crawlers has several built-in classifiers to discover data stored in various different formats, including JSON, CSV, Parquet, weblogs, and many database systems as well, such as RDS, Redshift, and DynamoDB. And these classifiers can also be used against S3 files compressed with zip, bzip, gzip, LZ4, and snappy formats. So basically, when data does not fit a native classification, you can actually define your own custom classifiers using something called grok patterns, or also XML tags, JSON paths, or CSV. And by design, a classifier reads the data in a data store. So if it recognizes the format of the data, it then generates a schema. So the logic goes kind of like this. Glue invokes a custom classifier first in the order that you specify them when you create the crawler definition. Then during the processing, if a classifier returns certainty equals to 1.0, it means 100% certainty that it can create the correct schema. So Glue then uses that output of that classifier for the schema. But if no classifier returns certainty equals to 1.0, Glue then uses the output of the classifier that has the highest certainty among all the results. And if no classifier returns a certainty greater than 0.0, Glue returns the default classification string of unknown. Also, depending on the results that are returned from the custom classifiers, Glue might also invoke built-in classifiers as well. And one last thing to keep in mind is that changing or updating a custom classifier may result in an updated schema. So keep that in mind. All right, so Grok, as I mentioned, is a tool that is used to parse text data based on the matching Grok pattern, which is basically a set of regular expressions that parses data one line at a time. So if you're not aware of Grok, here's a snippet showing how it looks like. And in the first two lines of the slide, you can see it, how it works, how it looks like. And when a Grok pattern matches your data, Glue uses these patterns to determine the structure of your data and map it to the fields, as I previously mentioned. And as you can see here, Glue also provides many built-in patterns, or you can also define your own. So you can basically create a Grok pattern using built-in patterns and custom patterns and your custom classifier definitions the way you want it. You can actually play around and build your own. But before we move on, let's also learn how the crawlers can detect the schema and partitions. Basically, when a Glue crawler scans Amazon S3 and detects multiple folders in a bucket, it determines the root of the table in the folder structure and which folders are partitions of that particular table. The name of the table is based on the S3 prefix or the folder name. And we first look at the similarity among schemas at the file level, and then we aggregate it on up. And if similarity is above a certain threshold, we actually assume these files or directories are part of the same table. That's how we know that they are part of the same table. Then we assign column names to the partitions as we go up on the list. If a name is not provided, we create a default one named partition N. What else? Okay, you can set which files to ignore, so the partition detection doesn't get confused with the metadata files. And you can also influence the crawler to create separate tables by actually adding each table's root folder as a separate data store when you are defining the crawler. You can actually do that. And then we have the Glue connectors. So a connector is an optional code package that assists with accessing data stores. Glue provides built-in support for the most commonly used data stores like Redshift, Aurora, SQL Server, MySQL, MongoDB, and PostgreSQL using the JDBC connections. And Glue also allows you to use custom JDBC drivers in Edl Jobs. However, for data stores that are not natively supported, such as SaaS applications, you can use connectors. Connectors and connections, they kind of work together to facilitate access to the data stores. So in summary, when you are creating an Edl Jobs, you can use a natively supported data store, a connector from the marketplace, or you can even build your own custom connectors. And building custom connectors is quite easy and flexible, and you can actually take a look at the reference link at the at the bottom of this slide if you want to learn more about how to do that. And okay, let's see all of these components that I showed you for data exploration. Let's see them in action. I have pre-recorded a demo. So the first part of this demo is part of a set of 3 demos that I'm going to show you today. And that builds up a scenario where all these topics will converge into one single use case. So let me show you this demo quickly, 1 second. In the first part of this demo, I'll show you how to create a crawler to catalog 15 tables based on sample data that simulates an initial full load of data. The crawler will detect the file type, extract the fields, and define the proper schemas for the tables. As you can see, the sample data is called DMS_sample, and it holds separated folders with CSV files for each table I want to crawl and catalog. In the Glue console, I click on crawlers and then add crawler. Next, I give the crawler a name. In that step, I can also add optional settings such as security settings, tags, and classifiers. But for this demo, I'm going just with the defaults. Next, I must choose the source of my data. I can either choose to crawl a particular data store or any existing catalog tables that I may have. I can also say if I want to crawl all the folders in my bucket or just new folders. Let's also go with the defaults here. As data store options, I have several options to choose from, but for this demo, I will be using S3 and configuring the path for my data in my S3 bucket. I am selecting the tickets folder and hoping the crawler to crawl all the underlying folders for me. We are not going to add any other data store, so I'll just click Next. And here I'm leaving up to Glue to create a required role with proper policies that will give my crawler access to the data and permissions to perform the actions that a crawler must be able to perform. Next, I must choose the frequency I want my crawler to run. Since I want to manually start this crawler, I will leave it run on demand. I will then create a new database to store the tables I'm cataloging named ticket data and define that only new columns should be added when schema changes are detected. Finally, we can just review everything we did so far, click on Finish and start the crawler manually since we choose to do it on demand. The crawler will take just a couple of minutes to run and you can see the status column changing throughout the process. More important, at the final stages, you can already see that 15 new tables were added to the ticket data database. Let's have a look at them. Here, we can confirm that all the 15 tables has been successfully crawled and that they point to the S3 location we first defined. There will be situations where the crawler defaults won't be able to infer the correct data types or the column names, for example. Please note that you can manually adjust and fix that whenever needed. Take the table person as an example. As you can see, the columns has default names such as column 0, column 1, column 2, and so on. You can manually edit this as well as the data types and key settings. Alright, for the second part of this demo, we will simulate CDC, changing data capture, or sometimes referred as delta changes. We will take two tables, sporting underscore event underscore ticket and ticket underscore purchase underscore hist, to simulate ongoing ticket purchases. Basically, I will be providing ongoing data to these tables and we will use another crawler to catalog this ongoing data. As you can see here in this S3 bucket, I have a new path called /cdc/dms underscore sample with two folders representing the locations for the CDC data that I will be further crawling into two new tables. Initially, each of these folders only contains one piece of CDC data, which will be enough for my crawler to infer this new table's schema, fields, and data types. So let's go ahead and create another crawler and name it glue-lab-cdc-crawler for easy reference. The next steps will be similar to the previous ones that we created, except that now we are choosing the DMS underscore sample folder that exists within our CDC path in our S3 bucket, which then contains the CDC data that we really want to crawl. Please note that I'm also reusing the same role for simplicity, but you could just create a new one if you want. The database will also be the same, ticket data, but now I want to give my tables a prefix so we can easily identify those tables once they get created. Again, once the crawler is created, we can run it manually and verify that it will generate two new tables, CDC underscore sporting underscore event underscore ticket and CDC underscore ticket underscore purchase underscore hist. Let's pause here for now. In the upcoming demos, we will continue from where we left off. All right, I hope you enjoyed the demo. Let me switch back to my screen. And now let's continue and take a look at the components that help us to developing and testing code, as well as building ETL scripts for our transformation now. So note that in this yellow arrow, that for today's session we will focus on the traditional methods and components used by the most experienced developers. But tomorrow I will reveal a new visual experience that is quite helpful for non-developer folks as well. Okay. So before Talking about altering glue jobs to do transformation, we must first understand what Apache Spark is and how it correlates with AWS Glue. Spark is a unified analytics engine for large-scale data processing. It provides a high-level APIs in Java, Scala, Python, and R, and an optimized engine that supports general execution graphs. It also supports a rich set of higher-level tools, which includes Spark SQL for SQL and structured data processing, MLlib for machine learning, GraphX for graph processing, and structured streaming for incremental computation and stream processing. And AWS Glue provides a managed ETL service that runs on a serverless Apache Spark environment. And this allows you to focus on your ETL job and not have to worry about configuring and managing the underlying compute resources as if you're running your own Spark cluster. And under Spark's hood, we find some important data interfaces, such as the RDD, which means Resilient Distributed Dataset. This is a fundamental data structure of Spark, and it is the primary data abstraction in Spark and the Spark core. RDDs are fault-tolerant, immutable, distributed collections of objects, which means once you create an RDD, you cannot change it. Each dataset in an RDD is divided into logical partitions, which can then be computed on different nodes of the computer or of the cluster. Then we have data frame, which is a distributed collection of data organized into named columns. It is very similar to a table in a relational database or a data frame in R or Python, but with richer optimizations under the hood. And data frames can be constructed from a wide array of sources, like structured data files, tables in Hive, external databases, or even existing RDDs. And there's also the dataset, which is a distributed collection of data. A dataset is a new interface added in Spark 1.6. It provides the benefits of RDD, strong typing, and ability to use the powerful Lambda, for example, with the benefits of Spark SQL's optimized execution engine. And at last, we have introduced dynamic frames, which is native to AWS Glue, and we will cover just soon. And Spark also allows you two kinds of operations: transformations, which are lazy operations like select, distinct, group by, and etc. And by lazy, it means that when you run a transformation, let's say an update, instead of updating a current RDD, this operations returns another RDD instead. And the second operation that it offers is the actions, which are the commands that are computed by Spark right at the time of their execution. They basically consist of running all the previous transformations in order to get back an actual result. And an action is composed of one or more jobs, which consists of tasks that will be executed by the workers in parallel whenever possible. All right, now that you are familiar with Spark, you should know that Glue offers a few different ways to alter your ETL scripts. That is because it uses open source programming language, like I said, like Python, Scala, and Spark, so you can easily port your code to and from different platforms at any point in time. As an example, you could use the AWS Glue code generator to write PySpark or Scala code for some of the commonly used transformations. Then you could take that auto-generated code as a baseline and further evolve it with additional custom code. And actually, you can actually use Glue notebooks to evolve it. And once done coding, testing, and evolving your code, you can actually bring that code back to Glue to run it as a Glue job. Or if you want, you can even create your own pre-created ETL script from scratch, upload it to S3, and use Glue to run the code as a Glue job. That's a lot of flexibility for sure. Okay, so to help you visualize what I have just mentioned, look at this simple slide here. It basically shows the possible ways you have to develop your scripts in Glue. As you can see, the dotted line in the center shows bringing automatically generated code to your notebook using a Glue Dev endpoint, which we'll just cover real soon in the next slides. And when running your jobs, AWS Glue runs them on a Apache Spark serverless environment, as I said, using virtual resources that Glue provisions and manages in its own service account. As I also mentioned, Spark provides flexible interfaces to different languages. Hence, Glue supports an extension of the PySpark Python dialect, as well as an extension of the PySpark Scala dialect for scripting your ETL jobs. And along with that, Glue libraries make it easy to write or auto-generate ETL scripts in addition to testing and running them. Whereas the Glue Data Catalog, which is an Apache Hive Metastore compatible catalog, also allows Spark SQL jobs to use it, the Glue Data Catalog, as an external Hive Metastore. Basically, you can directly run Spark SQL queries against the tables stored in the Glue Data Catalog. And also, Glue introduced the new component, which I mentioned, called Dynamic Frame. So let's dive deep into these two very important key concepts, the data frame and dynamic frames. A dynamic frame is a data set organized into named columns, as I said, which is conceptually equivalent to a table in a relational data set. A data frame API supports functional style operations such as map, reduce, filter, etc. And it also supports SQL operations like select, project, and aggregate. Data frames are powerful and widely used, but they have some limitations with respect to ETL operations because they require a schema to always be specified before any data is loaded, which is not always possible and can be actually very challenging. For example, let's say that you have a column containing a numeric value for some rows and then another data type for some other rows. With traditional Spark data frames, Spark will derive this as a string, which will be incorrect, and you would have to actually manually fine-tune this behavior later on. Similarly, imagine working with a deeply nested semi-structured data with varying schema. With a schema that varies a lot, meaning that the schema changes all the time. So without having predefined schemas and using the Spark data frame API, it will be just too complex for you to code that particular use case. So to address these limitations, that's why Glue introduced the Glue dynamic frame, because a dynamic frame, it is similar to Apache Spark data frame, except that each record is actually self-describing, so no schema is required at the beginning. With dynamic frame, Glue computes a schema on the fly whenever required, and it explicitly encodes schema's inconsistencies using a choice or maybe a union. That's how fancy data dynamic frames is. So essentially, dynamic frames basically provides a lot of schema flexibility, especially for semi-structured data such as JSON. And it also provides a set of advanced transformations specially designed for dynamic frames. With dynamic frame, you can have a variable schema, as I mentioned, with a single column having different data types over time. For example, let's say that you have a price attribute in your JSON dataset. It may have few numeric values such as 100, 110, 120, 130, etc. It may also contain few values in a string format that looks like 100.00 or $100.00, all within double quotes. So to overcome this problem, you could simply use dynamic frames to solve that issue. For example, the resolve choice function of the Glue dynamic frame would simply split this column into two columns, column B1 and B2 on the fly, where the B1 would hold the numeric values, whereas the B2 would just hold the string values. Or even further, you can even cast all the string values to numeric using these dynamic frames capabilities. So like I said, dynamic frame infers schema on the fly, so it simplifies the cleanup and transform activities because it does everything in a single pass instead of a multi-step process. It really brings better performance to the overall jobs, as I said. Okay, so let's take a closer look into some of the most interesting advanced transformations provided by these dynamic frames. And this one is the relationalized dynamic frame transform function. And you can use this function to flatten a deep nested semi-structured data set, such as a JSON document, into a relational schema without the need of complex coding, actually. So with the relationalized function, the output column names, it uses a dot notation to represent child attributes in a nested document. And whenever you have a nested array, it simplifies that structure by creating a separated table, another table, maintaining the primary and the foreign relationship between them. For example, let's say you have a nested array data set for IMDb movies, for example, where the data set has an array of title, release date, and cast, where cast is a nested array of attributes such as actor's name, director's name, and editor's name. If you use this function, then it will actually create two tables, a title table with columns like name, release date, and cast, and a second table, the cast table, with columns like cast, actor, directory, and editor. And this cast column in both the tables will have a primary foreign key relationship to build the referential integrity between them. So why would you want to do this? Why would you want to use this function? Well, you normally get faster performance when you run SQL queries against relational schema as compared to when you run the same against nested JSON. So I think for me, this is a pretty good reason to do that. And there are also several dynamic frame transformations available to you that you can include in your Glue ETL scripts. Some of the supported transforms are listed here in this slide. Basically, with these functions, you can do a variety of transformations like dropping fields, cleaning new values, joining multiple data sets from different sources and schema, manage complex arrays or nested data sets, as I showed you, and actually relationalize them, splitting them into different columns and rows, all of that without writing complex code. Glue also provides machine learning capabilities to create custom transforms to cleanse your data. The find matches transform enables you to identify duplicate or matching records in your data set. So even when the records do not really have a common unique identifier or no fields match exactly. And again, this will not require you to write any code or require you to know how machine learning really works. You basically teach this ML transform by labeling example data sets to indicate which rows are matched. And the more you teach it with example labeled data, the more it learns which rows should be matches. And you can add the find matches transform to your Glue Edl jobs to solve a variety of problems like matching customers by, for example, linking customers' records across different customers' databases, even when many customers' fields do not really match exactly across databases, maybe different name spelling, addresses are different, missing, or there are inaccurate data. And you can also use for matching products in your catalog against other product sources. For example, a product catalog against a competitor's catalog where the entries are actually structured differently. You can compare that. Or to also improve fraud detection by identifying duplicate customers' accounts, determining when a newly created account is or might be a match for a previously known fraudulent user, and many other matching problems such as match address, moves, movies, parts, leads, etc. So the bottom line here is that if a human being could look at your data to your database rows and they could determine that they were a match, then there is a really good chance that this find matches transform can also help you to do the same. And because Glue is able to generate transformation code for you in the background into a human readable format that is editable and portable, customization becomes really easy to implement in AWS Glue. Because you can choose to use native PI Spark or Scala code. You can also import custom libraries, or you can even leverage Glue's extensive libraries along with the Spark libraries. And the code that you write, it can actually be shared via GitHub and it can be reused across jobs, which really makes AWS Glue a very collaborative tool. So you should make use of this capability of sharing your code in GitHub if you can. But although we are very fond of Glue's dynamic data frames, it is needless to say that Apache Spark's data frame API also offers a very rich, powerful, and diverse set of complex transformations. That is why it is very important for developers to understand they can actually take advantage of both worlds, the AWS Glues and the Sparks transformation at the same time. So it is imperative for them to know that they can actually convert between Glue dynamic frames to Spark data frames and vice versa. Basically, when you're writing your code, you have two class functions that enables you to make that kind of switch. So you have the from df, which converts an Apache Spark data frame to the Glue dynamic frame. And you also have the to_df that converts the Glue dynamic frame back to the Spark data frame. And besides that, if at some point in your project your job needs custom Python libraries, dependent jars, or additional configuration files, for example, you can simply load them into S3 and point it into to your job as parameters. Really simple. All right, finally, let's understand what a development endpoint is. So essentially, a dev endpoint is an environment that you can use to develop and test your Glue scripts. You basically provide configuration values to provision the development environments, and these values tell Glue how to set up the network so that you can access the dev endpoint securely, and that the dev endpoint can actually access your data stores securely as well. Once you have the endpoint set up, you can connect to the dev endpoint using a notebook to actually alter and test your ETL scripts. These notebooks are available within Glue console, or you can even use your own preferred IDE tool, such as IntelliJ or PyCharm or any other that can be supported. You can think of a dev endpoint as a virtual machine with CPU and memory that you actually pay by use, and then you just go and run your code. So following the development flow that we have started since the beginning of this presentation, once you get that auto-generated baseline script, remember that we are working on, you can start the unit testing that code and then enrich it with some additional code, maybe using Jupyter or Zeppelin notebooks through a connected dev endpoint. That's why they are meant for. And just before we jump to the next demo, it is again worth to mention that we have GitHub repositories with Glue sample codes that covers the most commonly used ETL operations. And we do recommend that you reuse these sample codes in order to ease your development process whenever you are actually dealing with common ETL operations. And also, if you use your own IDE such as IntelliJ or PyCharm, you can download the AWS Glue Python package, which includes libraries used in the AWS Glue services and allows you to run, for example, Glue PI Spark Shell, Glue Spark Submit, and the PI test locally on your computer. Cool. I have pre-recorded this demo just to show you how we can easily use Glue Dev endpoints to run ML transformations within notebooks. This is not part of the sequence that I mentioned first for the 3 demos, but we are going to catch up with that later on. So let me share this video real quick. I hope you can see my screen. So here we go. In this demo, we are demonstrating the use of AWS Glue ML Transform. In this scenario, a business user raised an issue about bad customer data for Tracy, claiming that the same customer has been duplicated. Traditionally, All right, looks like we're having some problems. Let me try to play the video again from the start, if that helps. And Sunita, please let me know if you can see it from your side. Okay. Okay, can you guys see my screen now? Sunita, can you confirm?
Victor, this is Karen. Yeah, it doesn't seem to be progressing or playing.
Okay, yeah, it's in the black screen. So let me share the video again, and then you tell me if it's running. In this demo, we are demonstrating the use of AWS Glue ML Transform. In this scenario, a business user raised an issue about bad customer data for Tracy, claiming that the same customer has been duplicated. Traditionally, data engineers will need to develop complex business rules to clean up this data, but with Glue, we use machine learned transform to clean up this data. We will be using Glue's Find Matches machine learned transform to identify duplicate customers. We first add a machine learning transform on AWS Glue page. I will call it Customer Matching Transform. Then I select the customer table from Glue Data Catalog and I also choose a primary key. Next, we choose a tuning option. I will choose the option to find fewer incorrect matches, and I am also choosing balance between accuracy and cost. You have options to use more resources to find better matches. Let's click Finish. That's it. We have created an ML transform. Now we are going to train the ML. For this, we will first generate a label file. Glue will automatically generate a label file for us to start training. We can see that the label file is getting generated. Once it's done, we can start the labeling process. We apply same labels to customers whose names are misspelled or whose addresses did not match. This label file acts as inputs to teach the Glue find matching algorithm. Notice how the same labels are applied to duplicate customer records. Let's now upload the label file by clicking Teach Transform and uploading the label file. Click Finish. We have now uploaded the label file and the algorithm is trained and ready to use. That means we are now ready to develop Glue Job to handle the duplicates. Glue offers development tools for every persona, and this time I'm going to choose a different development experience, a notebook-style experience. Data engineers love notebooks, and a dev endpoint is a notebook-based development experience where you can interactively develop Glue jobs. When you create a dev endpoint, you get a serverless Spark environment for you to run Glue jobs and a serverless Jupyter notebook to develop Glue jobs. In this block of code, we are reading customer data set that is not clean. In the next block of code, let's invoke the machine learning model we have just trained to clean customer data. And as you can see, with just one line of code, we have identified duplicate records which would have otherwise taken hundreds of lines of business rules. Let's interactively query the data and see the results. As you can see here, Glue has given us a match ID that tells us all the customers who are duplicates. This can now be fed back to end users via user interface that can be powered by Amazon Amplify or Amazon Honey Code, for example. Or we could simply apply business rules within Glue itself just to pick up the latest customer record. We can also package this as a Glue job and run it on a regular basis. All right, so I hope you enjoyed the ML video and you're back to my screen now. It's a black screen, so let me move on. And congratulations, actually, we are halfway through our journey. And so far we have discovered and cataloged our data, and we have also coded our jobs. And now let's see the options we have for running these jobs and understand how Glue actually behaves when these jobs are running. Let's start by breaking down a job into pieces to understand its anatomy. A job in AWS Glue encompasses the code it is supposed to execute and the properties associated with that job. Properties like the instance type, for example, will determine the amount of CPU and memory you want to leverage for this particular job to run. And you can also define properties for security configurations, such as an IAM role, as well as you can decide if you want to enable job bookmarks in order to force a job to resume from where it left off. We will cover job bookmarks soon. And whether you want monitoring and logging to be available for these jobs. And additionally, there are some other job properties like timeouts, concurrency, retries, etc., that you can play around with it with your own jobs. And once you develop the job script with all the necessary properties and required libraries specifically designed for your job, you simply deploy the job and let the AWS Glue managed environment do the work. But what does do the work really mean? First, again, AWS Glue is serverless, meaning that you don't have to provision or deprovision resources. You just need to specify the allocated capacity for each job by choosing a worker type and the number of workers. The resources are then provisioned on the fly when you execute an ETL job or a crawler, and they are deprovisioned once this job completes. The AWS Glue Job system provides the managed infrastructure that is necessary to orchestrate your entire ETL workflow. Each job scheduled in AWS Glue can elastically change the compute power based on the workload needs, thanks to something called auto-scaling. I think we all know the auto-scaling feature. You can create jobs in Glue to automate the scripts you use to extract, transform, and transfer data into different locations, and the jobs can also be scheduled and chained together, or they can also be triggered by events such as the arrival of new data, for example. And the best part of it, you only pay for what you are actually using while you are using. So you don't pay for stopped jobs or stopped crawlers. Only when they are running is that when you're stop paying. And to estimate how fast or slow your job will perform on Glue, you must predefine the amount of resources allocated for that job. You do this by specifying the number and the type of the workers for the job. Thus, it is very important to understand the correlation between worker types and DPU. Worker types are mapped to data processing units, also known as DPUs, that determines the individual worker capacity. A Glue DPU is a relative measure of processing power that consists of 4 virtual CPUs of compute capacity and 16 gigabytes of memory. You can choose between predefined worker types, like the standard G1X and the G2X. Both the standard and the G1X workers, they map to 1 DPU, each of which can run 8 concurrent tests. And a G2X worker maps to 2 DPUs, which can then run 16 concurrent tests. As a result, compute-intensive Glue jobs that possess a high degree of data parallelism can benefit from horizontal scaling, meaning adding more standard or G1X workers. At the same time, Glue jobs that need high memory or ample disk space to store intermediate shuffle output can benefit from vertical scaling, meaning more G1X or more G2X workers. And the maximum number of workers you can define to a particular job are 299 for G1X and 149 for G2X. However, you must pay attention to the number of available IPs you have in your subnet before increasing these DPUs. Always make sure that there are enough IPs to accommodate accordingly and that no other service component is consuming any IP in that particular subnet. Okay. All right, so job bookmarks. And as part of controlling and tracking data processed by jobs, you can use something called job bookmarks. A job bookmark is composed of the states of various elements of jobs, such as sources, transformations, and the targets. With job bookmarks, you can process new data and without worrying about reprocessing old data when running jobs on a scheduled interval. For example, let's say that you have an ETL job that reads new partitions in an Amazon S3 file. Glue will track which partitions the job has processed successfully in order to prevent duplicate processing and duplicated data in the job's target data store in case the job is running on a recurring scheduled interval. You can pass on parameter values to the job definition to actually control the bookmark behavior. These values can be enabled, disabled, and paused, as you can see in this slide here. And the job bookmarks are implemented for JDBC data sources, which uses one or more columns as bookmark keys in order to determine new and old process data. And in this case, you can specify the keys yourself as long as they are strictly monotonically increasing or decreasing, or you can leave it up to Glue to decide as long as Glue can pick up a key that is sequentially increasing or decreasing and it has no gaps. The relationalized transform also supports job bookmarks as well as some Amazon S3 sources to also support job bookmarks, as long as the S3 sources formats are JSON, CSV, Avro, and XML. And one more thing, in case you want to reprocess old data, you can also reset the job bookmarks. So to actually build your jobs, there are 3 different types of jobs in Glue: Spark jobs, Spark streaming jobs, and Python shell jobs. Regarding Spark jobs, AWS Glue released the version 2.0 of Glue that features Spark ETL jobs that starts 10 times faster. So now you can create new Glue Spark ETL jobs or moving existing Glue Spark ETL jobs to this new Glue version 2.0 if you want. With version 2.0, job startup delay is much more predictable and it has much less overhead. In addition, Glue 2.0 Spark jobs are built in 1-second increments with a 10 times lower minimum billing duration. So it's coming from a 10-minute minimum previously to a 1-minute minimum now. As a result, customers can now run micro-batch, deadline-sensitive, interactive workloads much more cost-effectively. And this can be micro-batch jobs to quickly load data lakes, data warehouses, and databases, and also enable real-time analytics. Because with faster job start times, customers can now run SLA-driven data pipelines much more reliably. Essentially, faster job start times enables interactive data exploration and experimentation. That's the whole point. And there's also Python shell jobs that you can leverage in AWS Glue to run small to medium-sized generic tasks that are often part of an ETL workflow. Previously, Python shell jobs in Glue were only compatible with Python 2.7, but now you can also run scripts using Python shell jobs that are compatible with Python 3.6. The environment for running Python shell jobs supports several libraries such as Boto3, NumPy, SkyPy, Pandas, Skylearn, PyGreSQL, and many others. However, although most of the features that are available for Apache Spark jobs are also available for Python shell jobs, unfortunately, you cannot use job bookmarks with Python shell jobs. But in terms of performance and pricing, by default, Glue allocates 0.0625 DPU to each Python shell job. So it is just a portion of a DPU to the Python shell job. And you are billed 44 cents per DPU hour in increments of 1 second, rounded up to the nearest second, with a minimum 1 minute minimum duration for each job of the type Python shell. And a third and more dynamic option to run jobs in Glue are the streaming ETL jobs. So with streaming ETL feature, you can create streaming jobs that run continuously, consuming data streaming sources like Kinesis data stream, Apache Kafka, and MSK. And this feature is built on top of the Apache Spark structured streaming engine, and it is able to automatically detect the schema of incoming records and gracefully handle the schema changes on per record basis. The job cleanses, transforms the data, and loads the results into the Amazon S3 data lakes or the JDBC data stores that you have. You have the option to use both Glue built-in transforms and transforms that are native to Spark structured streaming. And this feature also simplifies processing event data basically data coming from IoT streams, click streams, and also network logs in AWS. And a Glue job of Spark streaming type requires a minimum of 2 DPUs. By default, Glue allocates 5 DPUs to each Spark streaming job. And you are also billed 44 cents per DPU hour in increments of 1 second, rounded up to the nearest second, but now with a 10-minute minimum duration for each job of the type Spark streaming. All right, so since we're talking about streaming ETL, know that every modern organization in every industry use data streaming technologies like MSK, Kafka, and Kinesis to capture and distribute data generated by applications, websites, or machines. However, you must also know that it's very hard to coordinate data formats and structures or schemas across so many systems owned by so many different teams. That's because very often downstream teams have to build complex tools or custom codes to ensure data continuity when formats change or when the schemas evolve. The Glue schema registry prevents such downstream failures caused by those schema changes. And at the same time, it also boosts productivity for developers by enforcing schemas where data is produced before the data gets sent downstream. And also, there's an open source serializer provided by the schema register that will serialize the data into a compact binary and compressed format, which actually saves on data transfer and data and storage costs. So it's really interesting feature. So, all right, let's shift the gears a little bit here and talk about generating and monitoring metrics. Okay, so by default, Glue metrics are sent to Amazon CloudWatch automatically. And when jobs and crawlers are running, you can monitor them using the CloudWatch, which collects and processes raw data from AWS Glue into readable near real-time metrics. And you can also profile and monitor Glue operations using something called AWS Glue Job Profiler. When you enable profiling for a job through the Glue console or as a parameter for that job, it also collects and processes that raw data from the Glue jobs into readable near real-time metrics. These statistics are retained and aggregated in CloudWatch so that you can access historical information for actually to get a better perspective on how your application is performing. 1 second. And Glue also supports real-time continuous logging for AWS Glue jobs. And when continuous logging is enabled for a job, you can view real-time logs using the AWS Glue console, the Amazon CloudWatch console, or for the other jobs, you can also view the real-time logs under the job history. This will actually take you to the CloudWatch console where you can see all the Spark's driver logs, executor logs, and also an Apache Spark job progress bar for that particular job run. And apart from CloudWatch, you can also use the Apache Spark Web UI to monitor and debug Glue ETL jobs running under the AWS Glue Job system, as well as Spark applications running on the AWS Glue Dev endpoints. So in the Spark UI, you can check things such as the event timeline for each Spark stage, the physical and logical plans for Spark SQL queries, and also Spark environmental variables for each job, for example. And keep in mind that you can also use CloudWatch events to automate your AWS services and respond automatically to system events, such as an application availability issues or resource changes. And the events from AWS services are delivered to CloudWatch events in near real time, as I said. And you can create a conditional trigger when you specify a list of jobs and crawlers to watch. So for each watched job or crawler, you can specify a status to watch for, such as succeeded, failed, timeout, and so on. And the trigger will fire whenever the watched job or crawler terminate with that specified statuses. You can configure the trigger to fire when any or all of the watched events actually occurred. And you can also use CloudWatch events to write simple rules that indicates which events are of your interest and what automated actions to take when a certain event matches a certain rule. So for example, you could activate a Lambda function when an ETL job succeeds, or you could, for example, notify an SNS topic when an ETL job fails. And now let's catch up with our initial demo to continue our use case and to demonstrate the components we have seen in this section right now. Let me play another demo for you. Please let me know if you can see it this time. Let's have a quick recap. In the first demo I presented, we learned how to create crawlers and how we have used crawlers to crawl to tables that receives ongoing updates, also known as change data capture or delta data. However, the ongoing data is coming in CSV format, so we need a way to transform it into Parquet format. Also, since this is ongoing data, we also need a way to guarantee that old processed files don't get reprocessed again over and over. So only new files will get processed every time. To achieve both goals, we are going to create a glue job that uses job bookmarks. Under the ETL label in the Glue console, click on Jobs, then Add Jobs. Give the job a name and choose an IAM role with all the appropriate permissions as you see in the screen. We are using Spark as type because we want to run an Apache Spark ETL script. We are also using Glue version 2.0 with Spark 2.4 and Python 3. For this demo, I'm leveraging AWS Glue to auto-generate the script's code for me. You could also use an existing script you created or start authoring a brand new one from scratch. Next, use the default values for the following three directories, then expand the advanced properties, and that's where you actually enable job bookmark. With job bookmarks, you can process new data without worrying about reprocessing old data when rerunning jobs on a scheduled interval. Further, expand the monitoring options and check job metrics so CloudWatch metrics can be created when these jobs start to run, and hit Next. Now it's time to select a data source. Since we are simulating new tickets being sold, we are generating new ongoing data entries for the ticket underscore purchase underscore hist table. So let's select our CDC table that reflects that, named CDC underscore ticket underscore purchase underscore hist as our source, and then hit Next. In the next screen, I will keep the default selection of change schema as I'm not doing any machine learning here. Just hit Next. For our data target, I could either use one of my existing catalog tables or create a new table for it. Let's create a new table having Amazon S3 as data store. More important, here is where we actually choose the output format of our target data. In this case, I want my job to output data as Parquet in the following path that I am defining in my bucket, as you can see here. I will manually type the path that I wanted as being CDC underscore bookmark dash ticket underscore purchase underscore history dash data. Now I could either decide to add or remove columns in my target tables, as well as I could change data types if I wanted. I don't really need to do that right now, so I'm just saving my job as it is. And as you can see, AWS Glue auto-generates a script in Spark code that basically translates all the steps that I have followed so far into code. Clicking on the diagram flow in the left side highlights the part of the code that it represents. If I wanted, I could edit this script to do further transformations. For this demo, I'm just fine with the code as it is, so I'm just running it with all the defaults. The job will take a while to complete, but once it finishes, I can go back to my S3 bucket and I expect to see a new path there just like the one I previously defined in my job. And here we go, CDC underscore bookmark, then ticket underscore purchase underscore history, then data. Within that folder, I can see my transformed Parquet data that my job was able to produce from my source table CDC underscore ticket underscore purchase underscore hist that I previously crawled and cataloged in our very first demo. Awesome. We now have CDC data in Parquet format that uses job bookmarks metadata to control processing of old and new data. All we need to do now is to crawl this new Parquet data so we can finally start querying it using Athena, for example. By now, we are all familiar with the crawling process. We give it a name for easy reference. We keep the defaults here, and next we choose the CDC underscore bookmark path where the Parquet files live. There's no need to add another data store, just hit next. Reuse the previously created IAM role for simplicity. Keep run on demand. Choose the existing database ticket data, and this time we want a new prefix. We can just use bookmark underscore Parquet underscore for easy reference. Hit next one more time, review everything and hit finish. Then just manually start the newly created bookmark underscore crawler. The crawler will take a couple of minutes to complete, and you will be able to see it created one new table in the ticket data database. Let's have a look at it. The created table is named bookmark underscore Parquet underscore ticket underscore purchase underscore history. Let's open it up in Athena and run our very first query over it. As you can see, a select star query limiting 10 rows is showing the results just fine. So as to prove that our table is being able to keep up with the ongoing data, let's run a first count of the rows. You can see I got around 9,000 rows, so let's make a note of that result. Now I'm going back to S3 to simulate more CSV data coming into our originally CDC tables, the sport underscore event ticket and the ticket underscore purchase underscore hist folders that we have. As you can see, each folder has now two files. Knowing that the CDC data has arrived, let's then run our previously created job once again and see what happens. I go back to jobs, then I select the job I created, Parquet with bookmarks, and I run it manually. We can see the job is running. Once the job succeeds, I can go back to Athena and verify if my table has incorporated the new ongoing data. Let's run the very same count query again. And there we go. The result now says 137,000 rows, so indeed something happened to our table. Let's note that number down. But wait, how can I make sure it was just new rows that were added and not duplicates? Well, that's the magic of bookmarks, and that's it. That is exactly what they are meant for. To prove that, if I had just reprocessed the same old file again, I would have at least the double of my first count, right? Something around 180,000 rows. Since I have less than that, I can rest assured that only the new data was incorporated into my table and no old files were reprocessed. In the last piece of demo for today's sessions, we will see how we can orchestrate everything that we did so far into a more automatic way by using AWS Glue workflows. All right, so we have just one more demo to go. But before that, let's finish up with the content. I hope you can see my screen. Okay, let me continue. So we are finally reached to the end of today's journey. So we have discovered and cataloged data, we coded our jobs and configured them to run. So what else is there for us to do? Well, we can repeat several of these previous steps manually, or we can simply automate what we have done. We can build complex workflows and orchestrate job executions through monitoring, alerting, and by triggering events. And that's what we're going to see in the next chapter here. So in AWS Glue, you can use Glue workflows to create ETL activities involved in multiple crawlers, jobs, and triggers. A workflow starts with a trigger, which is represented here with an inverted square or this green trapezoid here. And as the name suggests, a trigger can be triggered based on certain events, which we will look into a bit more details in the next slide. And these rounded square blocks here are the actual jobs that are gonna happen when the trigger triggers. And as each of these jobs completes, they yield a success or a failure status, and the developer can simply use this trigger to read the prior job status and use a condition such as upon failure, run a notification job, so the support team gets notified, or for example, upon success, run job 2, as you can see here in this example. Then when we get when this the support gets notified on a job failure, we can also choose to continue to run the subsequent jobs in the workflow until there is a job in the pipeline that is actually dependent on the failed job, upon which the workflow will finally complete. Okay. And a trigger, as I said, can be triggered based on certain events, and Glue offers different types of triggering mechanisms. You can trigger a job based on a schedule, like for a particular time of the day, or you can trigger the jobs based on demand by manually invoking them or by using a Lambda to do so. There is also an event-based invocation. So that's because Glue provides metrics for crawlers and jobs that you can monitor, and based on these metrics, you can automate the invocation of crawlers and jobs when a certain event-based triggers actually fires. Just like we have seen in the previous workflow, where a particular job succeeds or fails and a subsequent action was taken based on the previous job status. So pretty much the same. Such orchestration mechanism enables you to compose jobs globally with event-based dependencies, which actually makes easy to reuse work across organizations. This is possible due to the job status, which is stateful, and it is made available across the entire workflow. Simply put, if you use the Glue workflow canvas to design the workflow that I was trying to describe previously in the 2 slides, it would look like the one you see here in this picture. Then you might think, why would I need a visual tool to build a workflow? Well, some organizations might have complex ETL processes that might be best implemented using multiple dependent Glue jobs and crawlers. So using a Glue workflow, you can design a complex multi-job, multi-crawler ETL process that Glue can execute and track as a one single entity. Then with the AWS Glue console, it provides you a visual representation of the workflow as a graph. So it really gets much easier for you to manage your jobs. And once you create a workflow and specify the jobs, crawlers, and triggers in that workflow, like I said, you can run it on demand or on a scheduled basis. And each workflow manages the execution and monitoring of all its components. And as a workflow progresses and runs each component, it records the execution progresses and status, providing you with a large overview of the large task and also the details of each minor step in that workflow. And the less than great advantage of Glue workflows is that they can be parameterized and created via blueprints, which can then be shared to others. That's useful because some organizations might also have a set of similar ETL use cases that could benefit from being able to be parameterized into a single workflow to handle them all. And to address these needs, AWS Glue enables you to define blueprints, which provide a way to create and share workflows. So let's say in situations where you have a complex ETL process that could be that could be used for similar use cases, instead of creating a new workflow for each use case, you could simply create a single blueprint and allow people to register to it and then reuse it. Essentially, the blueprint specifies the jobs and crawlers to include in a workflow and the parameters which the workflow users will supply when they run the blueprint to create a particular workflow. Then, once you create a blueprint, you can reuse it for different departments, teams, and projects. So think of a blueprint as an ad hoc workflow that you can actually pass parameters to it, reuse it anywhere at any time. And with that, I'm reaching to the last demo. There's the third and final part of my 3 demo set that links to the first and the third demo. So this one shows the orchestration component in action. Let's go to it. Quick recap. At this point, we have created crawlers in order to catalog our tables, including 2 tables that receives ongoing updates. We have also transformed this ongoing CSV data into Parquet format. We did that using AWS Glue Jobs with Job Bookmark enabled in order to control the processing of old and new data. Finally, we crawl this transformed Parquet data in order to catalog a new table that we then queried using Amazon Athena. In this third and final sequence of the demos, you will learn how to orchestrate everything we have done so far using AWS Glue workflows. AWS Glue workflows can be used to create and execute complex ETL jobs involving multiple crawlers and jobs in an automated fashion. In the Glue console, under the ETL label, click on Workflows, then Add Workflow. You must give the workflow a name. If you want, you can also add a description to it. Click on Add Workflow button at the bottom to create a blank workflow canvas. To start adding steps to your workflow, click on the radio button close to it and a Graph tab will appear. Every workflow starts with a trigger that can be a schedule, event, or on-demand type of trigger. Click on Add Trigger button, then select the Add New tab and give the trigger a name. I am calling mine Trigger 1 for simplicity. I'm also adding a brief description. For the trigger type, I'm choosing On Demand because I want to manually start it on my own. Finally, click on Add. You will notice that a nice graph canvas will appear on the screen. Our trigger will show up there along with an arrow indicating what action will be triggered. We must define that action by clicking on Add Node. So here, I want my trigger to first start our Glue Lab CDC crawler that we previously created. So I am changing tabs to crawlers and selecting the glue-lab-cdc-crawler, then I click Add. My crawler is now represented in the canvas, and if I click on it, it will bring up another arrow which points to Add Trigger, where I must define my next action. I am clicking on Add Trigger and giving it a name as Trigger 2 again for simplicity, and we can also add a short description. This time, I want my second trigger to start only when all watched events has finished. That means only when my Glue Lab CDC crawler completes entirely. Then I just click Add. Every time I add a new trigger, I must also add a node that represents what resource the trigger is calling. Now I want this trigger 2 to call my Parkway with bookmark job, so I change again tabs to jobs, and now I select the job that I want and I click Add. We can already see our workflow taking form, so let's click on the job and add the next trigger. I will call it Trigger 3 and give it a simple description. The Trigger 3 must execute as soon as any of my watched events complete. In this case, as soon as my Parkway underscore with underscore bookmark job completes. And then I click on Add. Finally, all I need now is to call my final crawler, the glue underscore lab underscore cdc underscore bookmark underscore crawler, to simply crawl every new file generated by my previous Parkway job. So again, I click on Add Node, then switch to the Crawlers tab and choose my last crawler and click on Add. And that's it, the workflow is created. That doesn't mean it is running though, since I chose to start it on demand, so that means I must do it manually. But before we can run this workflow, let's again simulate our third batch of CDC data arriving to our folders in S3. As you can see here, I now have 3 files under each folder, but since I am using job bookmarks, only the third file should be processed. So let's go back quickly to Athena and run our account again just to make sure nothing has changed. As you can see, we are still getting about 137,000 rows. Let's then start the workflow and follow what is going on with it. The chain of steps is essentially, first, I start a trigger on demand. Then here we can see the CDC crawler running on top of my CDC data that is in CSV format. It will take some time to complete and update my 2 existing CDC tables. Once the first crawler completes, it will call Trigger 2, and as you can see here, Trigger 2 has automatically started my job already. As you know, this job will transform all the CSV data into Parkway while watching out for new files only, because it has bookmark enabled as we previously learned. Finally, once this job is done, we can see that Trigger 3 has automatically started our final crawler. This crawler will basically update the bookmark underscore parquet table in our catalog with the new CDC data so we can further query it using Athena like we just did previously. It looks like everything runs smoothly and the workflow says completed. Let's go back to Athena for the last time and check out our counts. And there we go. Indeed, the workflow has orchestrated everything for me, and I do see my table has received the most recent data. Let's note this down one last time to conclude this demo. All right, that was my last demo. So now I need just more 3 minutes of your time to finish up the presentation. And that's the last pool of today. Let me present the pool to you guys quickly. Let me share my screen back again. Okay, I hope you can see it now. And this is the pool of the day. Please make sure you select this one. This is very important for feedback. So if it does not meet your expectation, let me know. We can improve it. We actually need your feedback to improve these things, these trainings. So please make sure that you vote. I see just 30% of you have voted. This is actually the most important pool for us, which we can actually track and improve our content. You also receive a survey where you can actually write down what you think and what you want to see next. So please complete that as well. All right, let me close the pool. Share the results. Wow, that's great. So for the most part, it actually met the expectation. We still have tomorrow's session to come, so hopefully I can cover that gap. And yeah, for the ones that are still not happy with the content, please share the feedback. We will be glad to update it. Let me close this, and I have just 3 more slides to go. So basically, I just want to remind you that if you want, you can run all the labs that I use to record my demos for this session on your own, and many other labs too, if you want to get your hands dirty. I really encourage you to do so. It's very fun, and you actually you learn a lot by doing that. But if you face any challenge, you can always email us. And you can also register to the PartnerCast portal to learn more, and we will find deep dive trainings on various different topics there. You can also differentiate yourself by going through the data and analytics competency and the service delivery programs, which will lead you to win and share more opportunities. And with this, we have reached to the end of today's session. Thanks for attending, and I hope to see you all tomorrow at the same time. Tomorrow we'll cover the second session of Mastering AWS Glue series. Really, thanks everyone for listening to me. Thank you so much.